We have already talked about the interval of convergence in the previous videos. Now, the interval of convergence of a power series is a set of all values of x for which the series converges. Now, and I've already talked about the fact that the endpoints may or may not converge. All right. Now, the radius of convergence is simply 1/2 way the interval of convergence, centered at the midpoint of the interval. And we use letter r to for the radius of convergence. And I'll discuss in the next examples how to find the radius of convergence. Now, these are just some key points here. If the radius, if the series converges only at one point, then the radius of convergence is 0. And if the series converges for all values of x, then the radius is said to be infinite. All right. Example 2. Find the radius and interval of convergence of this series. So we are going to use ratio test. Now, from previous examples, when I used ratio test, I started by writing a sub n, which is in this case n factorial x to the power n, and a sub n plus 1, which is n plus 1 factorial x to the power n plus 1. And then we can go ahead and plug this stuff in the ratio test. And the formula for ratio test. This will be equal to now I'm just going to rearrange this guys a little bit and expand the factorial bit in the numerator. This will be equal to, now that cancels out. Then this will be equal to, now we can factor out x. Remember, x is a dummy variable. It can take any values depending on the interval of convergence. And we are trying to find the limit as n approaches infinity. So x can be taken as a constant. Now, this will give us an interesting result. So we'll end up with absolute value of x multiplied by infinity, because so we have to be careful here, because how do we interpret this result? So the limit is infinite, but there's a term with the x in front of the limit. If you plug in x is equals to 0, then you will end up with 0 is less than 1, which means that the power series will converge when x is equals to 0. Remember the conditions of ratio test. You know, converges when whatever you have on the left is less than 1. So, and I just want to write this as a statement so that you can have it in your records as well. So if So the power series will converge when x is equals to 0, but it diverges for all other values of x. All right. Um, so we'll say hence the series diverges for all values of x except when x is equals to 0. Um, and because the series is just converging at one point, the radius of convergence will be equal to 0. So we'll add another statement and say okay. All right. Another example, determine the radius of convergence and interval of convergence for the following series. Now, again, we'll use the ratio test. So start with, you can start by writing what a sub n and a sub n plus 1 is. So a sub n. Plug this in the ratio test, the formula for ratio test. And then we have to simplify this. I'll expand this bit. Now, this bit here, you can simplify just by using indices. All right. So this will be equal to 2x plus 1. So we'll end up with this expression. This cancels. So that will be n plus 1 multiplied by 2x plus 1, which will be equal to absolute value of 2x plus 1. If you factor it out, multiplied by the limit of n plus 1 as n approaches infinity. This will be equal to absolute value of 2x plus 1 multiplied by infinity. Now, again, when this bit is equals to 0, then we shall end up with 0 is less than 1, which means the series will converge. Okay, it's similar to the previous example, but I'm just adding more details for you. So, and we can find that by just, equating that to 0. So, absolute value of here, absolute value of, can use a different color, which means, 2x plus 1 is equals to 0, x is equals to negative a half. So the series converges when x is equal to negative a half. So we can write that here. Um, so it diverges for all other values except when x is equals to a half, negative a half. So in this case, again, just like in the previous example, r is equals to 0. Okay? Because the series converges only at one point. All right.